Suppose that Kelly's trying to decide between two options. Option 1 is making month-end $200 deposits to her tax-free savings account. And option 2 is making $650 payments at the end of every 3 months, so every quarter. We want to try to figure out how much larger the option is with our higher future value after 20 years. And let's assume that money can earn 4.25% compounded annually. In both cases, since our interest rate is compounded annually and our payment frequencies are either going to be monthly or quarterly, we are going to have to calculate I2. So I've gone ahead, I've set up our two options. Option number 1 is our payment size $200. Option 2 is our payment size $650. For our $200 payment size, these are month-end payments. So I2 is going to have a power of 1 over 12 here. Whereas in option 2, since the $650 are quarterly, our power is going to change to 1 over 4 instead. So let's go ahead and calculate I2 in both cases. For option number 1, let's take our 1 plus 0.0425. And we're going to raise that to the power of 1 over 12. Remember to use brackets here, 1 divided by 12. Close that bracket, and then let's go ahead and subtract 1 from that. So we should get an I2 here of about 0.003. And let's go ahead and let's store that in number 9 so that we can recall that later. Next up, let's calculate the I2 value for option 2. So taking our 1 plus 0.0425. Let's close our bracket, and we need to raise this to the power of 1 over 4. So open bracket, 1 divided by 4, close that bracket. And let's go ahead and subtract 1 from that to get our I2 value. So this value of about 0.01, we want to save that just like we did for I2 for option 1. I'm going to go ahead, I'm going to store this under number 8 so that we can recall this later. Next, let's go ahead and try to calculate the future value of option number 1. Taking our payment size of 200, we're going to sub in I2 where we see I1, and let's try to figure out our power of n. Here we're making month-end deposits of $200 for 20 years. 20 times 12 gives us our value for n. We're going to have 240 of these equal-sized payments. Okay, so let's move over into our calculator. We're going to begin in the numerator of our fraction, 1 plus. We need to recall I2. It's stored under number 9. Close that bracket. We're going to raise that to the power of 240. Go ahead and subtract 1 from this value. And then we need to divide this by I2. So we're going to recall number 9 again. And we get about 373.84. We need to then multiply this by our payment size of 200. And that gives us a future value of about $74,768.06. Next, we want to apply the same strategy to option 2. We're just going to update our payment size to $650. And here, since we have quarterly payments happening for 20 years, we're going to have 80 of these equal-sized payments instead of 240. So let's again start inside the numerator of a fraction. We're going to go 1 plus. We need to recall I2, but here we need to recall number 8. Let's close that bracket, raise this to the power of 80, and go ahead and subtract 1. We need to divide this by I2, so we're going to divide by recall 8 and hit equals. Finally, we multiply this by our payment size of $650. That's going to give us a future value of about $80,717.96. So in conclusion, we see that the stronger option is option number 2, where we're going to deposit $650 at the end of every quarter. And after the span of 20 years, the difference between our two future values should be about $5,949.90.